Hello, can you hear me?
I can hear you.
Ken, we cannot hear you.
Yeah, we cannot.
The problem is only from my side, but I was double checking, so we could not hear a word of what you said from the start. So
I was talking to.
we can see your lips moving. You can see the slides. We can see the picture, but no audio from your side, Chen.
I guess we all thought it was our side. Yeah.
Well, they took
We
me
were
like
too polite to disturb.
yes.
Thanks,
And
Richard,
they did not want to mention this.
Yeah. So.
Thank you, Kai, for.
Yeah. I was switching my computer to my tablet actually.
We joined one more time. So.
I think that Louis also have the same issue. It's not your problem, Louis, if you can hear me. I think that Louis left the meeting too.
Yep.
In?
I'm here. Can you hear me?
Now we can hear you, yes.
Louis, can you hear us?
Yes, I can hear you.
Okay. It looks like Louis is back also.
Yeah.
Yeah. Okay, cool. Yep.
So Jody, can you hear me?
Yeah, we can hear you. Can you hear us?
Go ahead.
Okay. Sorry about that. Actually, I switched to my PC. My laptop maybe doesn't work, and yeah. So sorry about that. Actually, yeah. That's restart. Actually, yeah. This is Qing. Actually, this is third interim meeting. Actually, so thanks everyone to come to join this meeting, especially people who still in vacation actually make a make it to attend this meeting. And my name is Qing, and my co-chair is Mohammed. Actually, we both online to host this meeting, and so note where apply. Yeah, if you are not familiar, please read it. And first, I want to set the tone for this discussion. Actually, for we really want to foster the auto development, so we really want to know how many network data sources that can be integrated with auto server, what are readily available data source. So we'll focus on these available data sources that we already have operation deployment experience. And second, I want to emphasize, we not really identify or enumerate all the data source. Actually, we want to focus on some of these data sources with the handy tools, which already have widely deployed. So this agenda for today's discussion, first we will, invite Louis and Jody to discuss the survey on the list of the potential data source of interest. Thanks, Louis and Jody, to take leadership to do the homework for this part, and then we'll invite several proponents to introduce a proposal for data source integration, and so we have 40 minutes for the discussion for each proposal. We assign 10 minutes. So please stick to your time. So, and then we can wrap up the discussion. So let's kick off the discussion. And the first one, the Luis or Judy, who will present the first topic?
It's gonna be Luis. Luis, do you want to take it?
The community,
Okay.
right? Okay.
Yeah, Luis, do you want to share by yourself or?
Yeah,
Okay, I
it's
can try.
It's kind of
share
spreadsheet,
from your
right?
side. Yeah. Mhm.
Yeah. Okay,
Okay,
I
is
can.
it the spreadsheet we are referring to, right? Okay.
Yes.
Yes.
Right.
Okay, give me just 1 second. So, okay. Okay. Just 1 second. I will look for the. I need to look for the Google Sheet. I don't. Jordi,
Yeah.
do you have the?
Let me. I'll put it in the chat.
Yes, please.
So
That
let me
would
put it
be
in the chat. Yeah.
would be
I know you're
faster.
switching from another meeting, Luis. For it's, yeah.
So anyone who would like to take a minute, Richard or Jody?
Yeah. So I put that Google Doc. Is there? I'm happy to take the minutes, but any other volunteer?
Yeah, I can also take a minute.
Okay.
Okay,
Thanks.
Kai, I appreciate it. And if you talk, I can back you up. Yeah. Mhm.
So I guess you can see my screen, all of you, right?
Yes.
Yes.
Go
Okay,
ahead.
perfect. So I will go ahead. Yeah, well, the basic idea at the time of collecting this was essentially to identify useful and interesting data sources that could be integrated in Alto, right? So at the time of integrating data sources, there are like, let's see, three fundamental questions, no? How to collect it, how to process it, and how to present it. So probably in all these three axes, there is an impact on Alto. Here, what we've concentrated was to identify the impact in the terms of how to process it. Let's say what would be the artifacts in Alto that could be impacted somehow for the different data sources. So this is the impact that we reflect here. But for sure, there will be some impact on how we collect the data source, how we integrate at the end, and also how we present it to potential Alto clients, right? So yeah, we essentially our exercise was to identify those sources that could be of interest, trying to declare an objective for having these different data sources into Alto, then a rationale, why, I mean, a justification, a motivation for that, right? And then existing work for reference. This was essentially the exercise. Also comments in case that something should be somehow highlighted or reflected. So we started with basic aspects like the topology. In topology, we have a very good number of outcomes from IETF. We have the IETF network topology, we have the IETF-TE network topology, and so on and so forth. So a number of relevant topology models already being developed and deployed in actual networks. So yeah, the objective here essentially is to use Alto, or I mean, to leverage on components that already have these networks models, and use Alto to retrieve from them the information and to integrate with the rest of the information that could be part of Alto. For instance, there was a recent comment in the mailing list, was triggered by Kai, about the fact that, okay, from the topology, we can collect, let's say, the internals of the connectivity of the different nodes and links and so, but there is yet information missing that could be retrieved in some other way. That could be, for instance, the IP pools that are declared in different border routers, border nodes. No? Like, for instance, the IP addresses of residential users that is well exemplified, I guess, with the case of the Telefonica CDN integration of Alto, right? So we need yet, I mean, this would not be yet the only source of information for building an overall topology. We probably need to rely on some other information in order to aggregate all of that and build the full topology. So this is, and for sure, please interrupt me whenever you want. So I will go one by one, but if I should focus on concentrating in someone, please let me know. So, for instance, in these two cases, the topology, and in the case of the raw IETF network topology, probably the impact is in the network map, how we do form the topology, taking into account this data source. In the case of the TE network topology, the impact would be not only in the network map, so how I build the topology view of in Alto, but also in the cost map in the metrics, because we are incorporating traffic engineering information on top of that. Okay. Third case would be the performance metrics. This already there is a document close to become RFC in Alto where we declare how to present the Alto performance metrics, but it's not yet clear at all how we collect the performance metrics, right? So how we integrate those performance metrics together with the topology to be presented in line with this graph is presented, right? So here, essentially, the point here would be to analyze, to understand how we can integrate such performance metrics, relying on BGPLS or in IGP, carrying this performance information, and so on and so far. Here, clearly, the impact would be on the cost map, so how we build the cost map, integrating those metrics that we identified so far in the previous draft. Then we commented on we identified also as relevant the compute resources. So the idea here would be to incorporate into Alto information related to the available compute resources connected to the network. And here, let me make a difference between the compute resources, the raw compute resources, versus the resources allocated to service functions. That would be the following topic. So here would be essentially the resources that are available in certain point in the network, or the resources you want, the resources that are attached to some point in the topology in the network, right? So the relevance of having this information would be, for instance, at the time of instantiating applications or instantiating services. Probably, would be very convenient to have an idea not only of the number of resources that I have available for such application, but also what are the network conditions for reaching those resources, right? In terms of latency, jitter, whatever performance metric probably that we have commented before. So yeah, here the impact will be on the network map, the topology, because we are extending the topology with other resources, right? And also the cost map, the metrics, because we are incorporating new metrics from an external domain that will be the compute domain. Then, as mentioned, the service functions. In this case, the idea would be to present information of service functions. So this is network functions or applications or services attached to certain points in the network. And also here, we can essentially incorporate information on what are the service functions available, where these service functions are located, and also probably even what are the resources allocated for those service functions. So this will be a matter of analysis, right? To what extent the information is relevant or not. Okay, in this case, as before, so there is an impact on the network topology because we need to incorporate further information that are the services that are instantiated in the network, in certain nodes in the network, in the border nodes, and also metrics that could be incorporated related to these service functions, right? And here, as a comment, we added that there will be a clear synergy, I guess, with what is being defined in CATS. Continuing with the exercise, we also consider as a potential metric a potential data source to integrate would be the available bandwidth in a given path. So to include this information about the available bandwidth in the path in such a way that we can take an informed decision at the time of placing some flows in given paths. Okay, there is also some work done in this respect, and here the impact we identify mostly on the cost map, because in principle the network topology doesn't change. What changes is a property of the network map, right? Seventh would be the energy consumption metrics. The idea here would be to provide information about the power consumption in a path or in a number of paths, right? So this is clearly of interest there is interest in IETF in the latest IETFs for exploring and working on this area. There has been some work in IAB. Also, there are some specific drafts in terms of green metrics. So here the point would be essentially to include this information about the power being consumed in a path together, as part of the cost map. So an additional metric to other existing metrics. The eighth data source of potential relevance would be inventory information. And here, by inventory, an example that we provide here, because it's related with one of the latest activities that has been discussed in the mailing list, could be, for instance, the geolocation of the nodes. So the geolocation at the end, the node has a property is where this node is being deployed physically, geographically, right? So a potential source to be integrated would be to take information from the inventory, for instance, and add this kind of information, this kind of properties into the network map. So in order to enrich the information of the network map, right? New services that could be relevant or impacted for this would be, for instance, aspects like geofencing, or that probably I mean, there is a decision behind avoiding certain paths or certain areas, and so on and so forth. And as I said, this this could be probably have some in synergy, let's say, with the work on inventory that is now being triggered in IETF, and also the trusted network activity from our colleagues from Fujitsu also could have some relation with this. The nine potential data source would be the one related to planned or scheduled variation of routing. And here there is a clear link with another working group in IETF, which is the TBR, where this working group is exploring this idea of scheduling, programming changes in the network, and then advertising those changes. So carrying this in IGP or BGP. But it's not only that case. Also, there will be other cases that, for instance, the declaration of IP pools in situations like CGNAT or APNs in a mobile network, where essentially operators are declaring new prefixes or prefixes that in day zero are in one location. Yes, sorry, change. Yes.
Yeah, you run out of time. Maybe we
okay.
can leave some time for take a question.
Yes, sure.
Yeah, I want to have some question for this table actually. So thanks for put it together for this data source. I think is very useful. I think yeah, what the missing part is, maybe we can add one column to say which data source actually already have an open source project, which data source has already been implemented, or which by either be by the open source or by the vendor or operator. I think BGP and nano topology actually are more concrete data source for nano topology has already been implemented by the Open Daylight, and for BGP already many vendor maybe already implement the BGP. So for some other data source you mentioned inventory. I think inventory not only they can to expose some of network device property, but also can expose some kind of endpoint property or device property.
Mm-hmm.
I mean the endpoint device. So this may relate to some kind of camera network as a service API project. They can expose like device information, device status. So inventory can help to expose this kind of information.
Yeah, even technology, for instance, you mentioned the devices, even the technology behind the device, for instance, saying if is accessing with fiber or Wi-Fi or whatever. Yeah, very
Yes.
good point. Yeah.
And also, for BGP, you only, list, BGP community. So as I commented on the list, we may also need to add BGP else. Maybe some other people can comment on for BGP this part. Daniel, do you have any experience to share here?
Hello, you hear me?
Yes, we can hear you.
Daniel from Venice. Yeah. Actually, I was thinking on the aspects regarding to the BGP information, because I remember Igmar mentioned it in the last IETF. That in terms of how we will collect the information, because Luis mentioned it, three key questions: how we will collect, how we will process, how we will present. And then we have a set of components running for almost half a decade. Ingmar mentioned that we have the core engine that actually collect information from the control plane, including IGP, BGP. And in the particular case of BGP, we basically, have reflector connections to all the border routers, and we use this routing information, including the BGP. That is just to mention that we have a set of components, and we have that currently are running, and in some point, we could take advantage of that to define how is the process, or how the data source is collected, and eventually how it's processed, just to try to answer some of the questions that Luis mentioned at the beginning of the presentation.
Okay. Thank you. Any other comments? If there's no comments, we can move on. Actually, we need to stick to the time. And I think the first, we can go to the second part, proposal for data source integration. And the first will be the BGP community. So, Luis.
This me again.
Yeah.
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 Thank you, Jim. Yeah, this is very, let's say, straightforward, rational, I guess. So the point is essentially the fact that we operators are very used to work with BGP communities. So it's a way of handling and identifying set of prefixes in the network for different operational purposes. For instance, in the slide, you can see one of the purposes, which is for the peering connections, and so to determine what is the local preference at the time of receiving the traffic, right? This is just an example. So the point is that somehow BGP community is an aggregation of information of different prefixes. So somehow it's similar to the concept of the PID in Alto, right? However, PID and BGP community could not be exactly the same. So somehow we could even consider defining BGP communities aggregating more than one PID, or alternatively, one PID having or aggregating more than one BGP community, for instance, fixed users, mobile users. So there could be different combinations. So we could have one-to-one, one-to-N, or N-to-one, depending on the purpose of the BGP community. So here, the very basic proposal would be to evolve Alto in such a way that we can work with the concept of BGP community. So somehow expanding the fact of having the PIDs, okay, but also work with the BGP communities in such a way that we can integrate existing processes in the operator side, leveraging on Alto for different kind of purposes, right? Essentially for determining, network code, network map, and cost map for those BGP communities, which is a visibility that we don't have necessarily today, because not always we have the one-to-one relationship between PID and BGP community. This would be essentially the summary.
Okay. So any comments for this proposal? Richard, go ahead.
Yeah, I think, Luis, this is a very interesting idea. Do you have any? I should read the proposal very carefully. Do you have any particular suggestion in terms of the protocol? In terms of both, in terms of modification of auto protocol, or also in terms of what BGP can carry? Because you talk about essentially this one can have impact on both sides, right? One is impact on auto protocol, one is have impact on the potential BGP carrier of communities. Can you give a very quick comment about what it might look like? For example, what's the extension on the BGP auto protocol? So are you saying, for example, we define cost map to say, hey, cost map 1 is associated with, for example, given a BGP community? Would that be a possibility? So therefore, we announce all this stuff in IRD. Is that one way to do it?
Well, in my view, essentially, that for sure this is open for discussion, right? So I will confirm my particular idea. So my particular idea would be potentially to create different network maps. So it would be network maps associated to PIDs and network maps associated to BGP communities. So this apply a different processing of the information. This is from the processing part. For the way of retrieving the information, also even BGP communities are advertised through BGP, I'm not sure it would be sufficient to listen to with a BGP speaker to collect this information, or if we would require something else at the time of defining the policies to have some consistency. Sorry, not the policies, the BGP communities, to have some consistency in the definition of BGP communities in the routers and also in the Alto. I'm not sure, to be honest, if just leveraging on a BGP speaker for collecting the information from BGP would be sufficient or not. And finally, at the time of presenting the information, probably we will require to modify the Alto protocol for asking for BGP communities. And here probably the clue is because BGP community can involve more than one PID, as defined today in Alto, is how we could handle and manage that information. I mean, if we will require something else, because involving more than one PID could, for instance, address a region rather than a single router. So somehow we were questioning through Alto protocol impact for a region. So let's put an example, performance metrics or whatever. So can we define a particular performance metric for a region or not? So probably something we need to think about. So what kind of information could be applicable in a straightforward manner for the BGP community? And work on that to understand if everything can be done similarly to the PID case, or we need to do something different.
Okay, that's very interesting. Very interesting.
Okay. So Luis, I have a comment actually. I try to figure out how BGP community is related to this PID. Whether you provide fine granularity for the PID, or you want to introduce a different type of endpoint group. Maybe you need to extend like endpoint map or entity map to add additional some property.
Yes, I guess that would be the case. As said before, the relationship with PID can be one-to-one, so then there is no discussion. It will be applicable essentially the same, but could be end-to-one or one-to-end. End-to-one, for instance, could be the case of a region. Consider, I don't know, a region where I live, Madrid area. Madrid area has multiple nodes. So a PID, as defined today, for instance, in the case of the CDN integration, we have one PID per node, but we can easily address all the regions. So creating the BGP community, impacting aggregating a number of PIDs, right? Reversely or alternatively, we could have a PID for a node that is aggregating fixed users and mobile users. Probably we could define different communities for fixed and mobile because, for instance, the different resolution of the content or whatever property that you would like. So for sure, I guess that with this granularity, either because we can be more granular or even we can zoom in and zoom out, probably we need to adapt the artifacts in Alto for reflecting this fact. And I'm sure that there will be some modifications in that respect. Yeah.
Okay, I think we can take it to the list to have further discussion for this open question.
Thank you.
Let's move to the second proposal and BGPRS. Oh, Sabine, do you want to make a comments for this? Sabine.
Can you hear me?
Yes, we can hear you.
I know we are running out of time, but maybe it would be good. Since Luis provided some examples, it would be good to formalize them in some further discussion or document to explain why, for example, it is okay. Sometimes you don't have a one-to-one map that justifies this work, and why it is not possible in case you define PID with respect to some geographical criteria, and within this geographical region you would like to define several BGP communities. So why it is then not possible just to define maybe a second network map that would subdivide these PIDs? Why it is not possible? Is it because of scalability, or maybe I missed something? Or so yeah, that was just a comment. So
Yeah, that's good comments. So provide example to show the limitation of the PID or existing the solution will be help people to better understand your idea. Okay, I think we can move to the next proposal, BGP LS, and Jason.
Okay.
Jason, go ahead.
Yeah. So, just want to summarize some experience and some practical use. For example, they try to deploy auto using the CC and the TPRI in our implementation. So, can go to the next slide. First, very quickly, progress update. It's so at first we have implement the auto next generation using the BPRS based on the OpenData TCP plugin, and then we report the some technical issues in the conference paper, and then proceed the Kentucky team, Louis and Kentucky actually move forward to do the deployment and try to migrate the our early implementation to the extra BGP, and it reported in the IETF 114 and 115. So you can go to the next page.
So Jason, can you see the slide? Do you want to run the slides by yourself?
Yeah, I can't see slide, but maybe there's some delay in my part. So
maybe I give the control to you, or you can request. Maybe I stop sharing.
Yeah, I can try.
Yeah.
Okay, so let's skip the progress updates and go to the details about so what we have done. So I assume you can see the slides, but yeah, I think it's still loaded. So for the deployment in a single AS, so we summarize some requirements to leverage the BGP and BGIs to generate the auto maps. So first, all the AS border routers must logically connect to at least one the BGP route reflector, and in each IGP area, the BGP RIs must be configured on at least one node. And in practice, because we want to minimize the number of the nodes to configure the BGP RIs, typically the BGP RIs is only configured on the area border router. So this is a figure for the testbed. We try the deployment in the test testbed, and all the nodes configured the BGP must locally connect to the at least one route reflector, and then the auto server if have a data source listener connected to this route reflector to get the information from the BGPOS and the BGP route update. And then the abstraction model we summarized for the BGP advice is traditional the update message we just need to generate the network map. So we need to use the path attributes and the prefix information. And so this process is very straightforward. We just need to, what we did is we use the AS number and the next hop to group the other prefix attached to the border router and use this information to generate the network map. And then for the cost map, so what we did is we use the BGPRS information, the link state LRI announcement. So it includes the three parts. It's a node descriptor, link to descriptor, and the prefix descriptor. And we use this link state information to first construct the IDP topology with the link metric, and then run the link state routing algorithm. It depends on what's the IDP protocol used by the IDP area. For example, use the OSPF or the ASX, and then we run the routing algorithm to compute the end-to-end routes secreted at the path vector. So with the path vector and the network map, we can compute the PID to PID cost and contrast the cost map. So that's the basic workflow. So to leverage the BGPS in a single AS. And then we found if we try to move this to the multiple AS, actually we found some known issues need to figure out. So one major known issue is that in a downstream AS, so for the end-to-end flow, we now know what's the ingress point for this flow. So there's some potential solutions to address this. So we can monitor the traffic to know what's the actual ingress point for the for given flow, and can also compute the path vector for all the potential ingress points, and waiting for the information from the upstream AS. But for this, we need some extension for the multi-domain settings, because this needs some information exchange between the different AS. And for the data encoding, we discussed yesterday. So the data source listener actually controls the different formats to store the information traced from the BGPS and the BGP. It depends on the implementation. So in our current practice, so in the open data, it can be the young data model, and in the actual BGP, it can be the JSON. So it's a matter because they all be equivalent to the abstract model we just described in the previous slide. And we also found some the useful some other useful BGP and BPRS extensions, and they can improve the workflow and the map computation in some different scenarios to get more accurate information, get more accurate cost information and the routing information. So I think that's the kind of progress on the inference we got. So we also want to see what the feedback from the working group and how to move this forward.
Yeah, thanks, Jason, for presentation. And so, any comments from audience for this proposal? And I think I want to make a few comments. You know, in your proposal, okay, Richard, you want to comment first?
Yeah, very quick question. So, of course, BGP-IS, even one of the main use cases of BGP-IS, one is auto, one is PCE. I'm always wondering because essentially you collect using BGP, we collect the essentially the topology, right? The nodes, the links and prefixes, and then the essential auto server would repeat the algorithm, right? Essentially to compute the route, to compute the route. But of course, in real life, sometime they might add a traffic engineer, right? So I'm kind of curious from maybe to Luis as well, for other people who are operators, how common there's traffic engineering paths, or very typical that in real life, essentially it's just purely OSPF in the sense, you know, or ISS, intra-domain IGP. Therefore, this information actually most time we mostly accurate. You are not going to have larger number of exceptions, meaning overlays traffic engineering paths on top of this shortest path, IGP paths.
Yeah, I think that's a good question. Anyone from operator who want to answer this question? Luis?
So I'm not sure if I understood properly. The question, Richard, was if how frequent is to have these traffic engineering paths. So I couldn't get you properly. Sorry.
So my understanding is the following: typical, because in most routers you have a relatively complex decision process, right? And you have a BGP to basically for every essential FIB, right? The forwarding engine and manager or whatever you call it. You have all kinds of route decisions, right? For example, you know, IGP, which I think using BGP-LS and with also the standard algorithm, you can compute the next hop. Yeah. And then you have BGP imported path. You also have, you know, you basically can learn the path from multiple sources. And then there's essentially a ranking system, right? A decision system to say, okay, I'm going to pick X. So therefore, my quick question is, BGP-IS essentially gives you one of the multiple sources, right? It gives you the source of essentially gives topology. Therefore, you emulate the decision process of the IGP. But then there are other traffic engineering override this one. Maybe it would be configured with higher priority for given destination. And then you might have BGP, you know, imported would give a higher decision process, you know, prefer IGP, prefer IGP over IBGP, prefer EBGP. So my question, typically in large scale systems, and how reliable this kind of emulation of IGP process using BGP-LS is accurate, or maybe that's not essential in real life. I guess, of course, like typical operators.
No, in real life, I mean, you trust fully on BGP and whatever other source. So at the end, BGP is aggregating all the information collected by the IGPs. Is clear, and with that you create the next hop info. So it's totally, I mean, it's business as usual. Yep.
Okay.
Okay, I think thanks for clarification. I think for this proposal, BGPLs, we really want to, focus on, the topology that can, connect using BGPLs. So Jason, you mentioned you use BGP update. I think maybe not really the relevant part of maybe, BGPLs will connect, node information, link information. We should focus on, how these kind of information can be mapped to the translated into the auto network map, cost map, how to compute, network map, cost map from this data source using, BGPLs. And maybe BGPL's young data model is, another interesting direction. I see, you list, Open Daylight already implement this BGPLs as, standalone young data model, similar to the BMP young data model. I think this could be, one of the direction we can, define some BGPLs young data model, and we can have this kind of data source. And second part, we should focus on how to compute the network map or cost map from this data source, maybe the traffic engineering database or LSP database. So this is something maybe more interesting part, but need more discussion. Yeah, I think. So Roland, do you have any comments?
Just a short comment from my side. So traffic engineering in general is of interest for us as operators. If you trust the poor, let's say, shortest path, then you get a little bit of asymmetric regarding the traffic in your network, and therefore we are today using tools like equal cost multipath, where we try to have some kind of distribution or load shifting balancing over our networks. And in that sense, if there is, let's say, some kind of information that can use, or we have an API that gets additional information in a sense compared to what it does network exposure information. I think this might be or is an interesting use case. It for sure depends and must be evaluated with other traffic engineering mechanisms that are available or in use, because here it's focusing, let's say, I would say, on the general traffic, and not only, let's say, that an application server can distribute traffic by or is handled. So we, in general, when we use traffic engineering, it is, let's say, traffic distribution or balancing over the network. And with Alto, we have some special additional requirements, which might be interesting in the sense that an application or certain features could have dedicated routing in that sense. I don't know whether this draft is covering this or just focusing only, let's say, on the lower layer. But I think this is something where I see in value, let's say, but that's my personal opinion.
Yeah, thanks, Ronan, to share your opinion. Maybe we can have more discussion on the list for this part. Yeah, I think my impression, first, this is just focus on, the lower layer, maybe underlay, but for overlay part, actually, maybe it's a conformed, complete end-to-end solution. Yeah, I think we can have more discussion on the list for this part. Yeah, I think let's move to the next proposal, compute. Jody, do you want to run your slides by yourself?
Yeah, I'm requesting to share this.
Yeah, probably we run out of time. We give you 6 minutes and.
Sure. Okay, so I'm gonna be sharing. Do you see my screen?
Yes.
Okay, so this is something that Liz and I have prepared, also coming from the IETF, the last IETF, in preparation of the Edge Services draft also. So that's this draft here, but as
have you shared already? We see it is coming, but haven't see
Okay, it's
Yeah.
actually, let me, now, yeah, you see it now? Yeah, I'm sharing the whole screen because
Yeah.
I'm gonna switch. Yep, okay. Yep, we're good?
Yes.
Yeah, thanks, Jim. So, yeah, but and this conversation is about extending Alto to support compute information. And as you know, this has been a topic that has been discussed for a while, different drafts actually, and one recent draft that we have revived also, the Service Edge draft, but dates all the way back to 2019. And of course, if you look at the history of Alto, starting with peer-to-peer networks, then evolving into CDNs, and now communication networks moving into the edge, basically, the importance of the edge and enabling all these applications, XR, distributed AI training, inference, IoT, which require stringent requirements, QoE requirements, right? The metaverse and so on. So and the way we think of Alto is that it's very well positioned as an API to help us expose this information to the application. And it's no longer enough to have communication information. We also need to have compute information, because the problems we need to tackle are about placing workloads, placement problems. So given our workload, say an AI distributed workload, how do you place that workload onto this set of compute nodes running in the edge and all the way to the cloud potentially? So we need to know not just communication information, bandwidth, latency, but also compute. Where are the CPUs, the GPUs, where is the memory and the storage, so that we can make optimized placement decisions. That's the motivation for this work. And coming also from Qualcomm, this is also where our interest is in, as we are.
Jody,
go ahead. Yeah.
You have 3 minutes.
Yeah, sure. No, my slides are actually going to be very fast because you can take them offline. Actually, what you see here is a table.
Can you share in full screen?
Sure. That we go through the set of potential APIs that are available. In blue are SDO standard APIs. In green are de facto standards. So this goes all the way through, scanning through AutoCADs, also RFC 7666 for virtual machines, DMTF, CNTT, and then going into the de facto standards like Kubernetes and OpenStack. This table, you can take it offline, but the way to think of this is that it gives us a way to understand what are the APIs available, what's the running code that's available, and to understand from where do we capture this information, how do we expose it. Then it goes into CAD's an Alto discussion. So this is the draft, the Service Edge draft that I mentioned, that we have revived, and so you can take it offline also and check the latest updates, where we actually show some use cases. A table comparing the AutoCAD's Alto versus CADs, also some of the things that we have been discussed in this group and also in the CADs working group. And then the slide deck just goes through these different APIs. So some examples of how do we extract compute information from Kubernetes. So examples of APIs, whether it's through the REST API or through the command line and interface, but you have information like memory, CPU. These are things that are very important for the problems we want to address, and so exposing this information to the application is relevant for us, to solve these placement problems. So this Kubernetes, same thing for OpenStack, examples of how this information can be queried, etc. So again, just scanning through what's available, whether it's a standard, an SDO standard or a de facto standard, and then this idea that Alto could be used as a single point of entry, as a neutral API. Some of these solutions like Kubernetes, OpenStack are domain-specific solutions or solution-specific technologies or APIs, and Alto is in this sweet spot where it's a neutral interface, it's an open standard, and so it could serve as a catalyst to help expose this information from a variety of sources in a neutral, way, basically. So that's the proposal here to help forward this idea of extending the protocol to incorporate computer information for the new problems we need to address. And also, again, of course, working with cats to avoid reinventing the wheel, and some of the work that Alto has already done. So I can probably stop here.
Okay.
This was very short, but you can take some of these things offline. Yeah.
Yeah, Jody, thanks for presentation. I think we need to. I think this work is also related to the cats. Maybe we should, let the cats people to know what is going on in auto and how this is related to the cats worker. Also, I'm very appreciate that you do a lot of homework to investigate the open source tool to use this open source tool to obtain or get the compute information. Maybe this should also be incorporated into your draft with some additional update.
Right.
Yeah.
Yeah, we plan to do that. Yeah.
Okay, I think we almost don't have time for the Chufang's presentation. Maybe we can skip this. And so anyone who have some last words for this presentation? Matt, do you have any comments on this?
For the comment, thanks.
Matt, okay. Probably, we can conclude this session, and I think we hear a lot of interesting proposal. We will, hope everybody can, post your proposal to the list, have further discussion with additional the question we raised on the list. We say how this question can be addressed.
Yeah, thanks, Chair. Thanks,
for
Jin. Do you have
just
a question? Do you have a suggestion for Chufang's talk, whether he should bring it offline to the mailing list or?
Xufang, maybe you can post to the mailing list for your ideas proposal. Well, what is the current status? How operator see this proposal, and we can see how to move forward.
I will do that. Okay.
Thank you very much. Yeah.
Thank you.
Okay. Thank you, everyone. Yeah, we can wrap up this discussion.
Sounds good.
Thank you.
Bye-bye.
Thank you all.
Thank you.
Bye.
Thank you all. Have a nice day.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.